We have all been there, right? You ask an AI to do something kind of complex, and for a second you get this flash of pure genius, but it's immediately followed by, well, confusing mess. The results can be incredible, but let's be honest, the process often feels totally chaotic and unpredictable. So today, we are going to pull back the curtain on a structured system that is designed to get you that genius-level analysis every single time.
All right, so we're going to break down this entire system, but we're going to do it a little bit backwards. We're going to start at the finish line with the absolutely incredible result that it can produce. What you're about to see is a really sophisticated piece of financial analysis that connects two huge and what seem to be totally separate trends. So here is the core finding. Taiwan Semiconductors, or TSMC's just unbelievable financial performance, it's not just market hype. It's actually a direct, predictable result of the trillions with a T of dollars that cloud providers like Amazon, Google, and Microsoft are pouring into building out their AI data centers. And this AI-generated report proves it with cold, hard numbers.
Now this slide, this is where it gets real. It breaks down that connection with actual numbers. Look at this. Over 5 years, a base case investment of $3.45 trillion in data centers directly creates a revenue pool of nearly $2 trillion for Taiwan's semiconductor industry. Now this isn't a guess, it's a forecast that's been built from the ground up, proving that TSMC's own projections are absolutely solid.
So getting to a clean, reliable output like that is the real magic trick, isn't it? I mean, it's one thing to analyze a static pile of data. It's a whole other ballgame when you need to bring in new and maybe even conflicting information without just breaking everything.
And yeah, this is the million-dollar question. What happens when new research drops with totally different numbers? How do you stop the AI from just getting confused, mashing it all together, and completely corrupting its own carefully built analysis? This image just perfectly illustrates the problem. On the left, that's what happens when you just throw prompts at a generic AI. You get chaos, it loses context, it forgets what you told it 5 minutes ago, and the scope of the project just bleeds everywhere. But on the right, you see order. And that order is achieved through a structured, layered approach. So how do we get from the chaos on the left to the order on the right? Well, the solution isn't about finding some magical, perfect prompt. It's about building a structured system for the AI to actually work inside of, what you can think of as an AI operating system. And this right here is the core philosophy. A truly effective AI doesn't get there by luck. It gets there because it's working inside a well-designed, disciplined environment that guides its every single move. You literally have to build its world. So at the heart of this AI OS is a concept called the 4-layer control matrix, which you can see right here. Now, instead of one giant, messy prompt, it actually separates all of your instructions into 4 distinct layers of control, each with its own very specific job.
Okay, so at the very foundation, we have the persona layer. This is not just about saying act like an expert, no. This injects a deep cognitive style. You're forcing the AI to adopt the specific mindset, the vocabulary, and the structural approach of, in this case, a top-tier financial analyst. Building on top of that, the next layer up is the project. This sets the local rules. So, for this specific task, what are the approved methodologies? What are the immediate do's and don'ts? It keeps the AI laser-focused on the job right in front of it. The next layer, the workspace, is like the strategic map of the entire operation. It defines the big picture. It understands how all the different data sources and folders and projects all fit together. And finally, at the very top is the root layer. You should think of this as the supreme law of the land. It enforces the non-negotiable global rules for the entire system, and it acts as a master guardrail to prevent the AI from ever going rogue. So that's the theory. Now let's get to the good stuff. Let's walk through exactly how this AI operating system was used in the real world to create that incredible TSMC report we saw earlier. It really all boils down to 5 key steps. This is the blueprint that transforms a simple request into a professional, reliable analysis. It involves 5 critical steps. First, you give the AI a specific persona. Second, you force it to plan before it executes. Third, you set strict boundaries. Fourth, you contain any new and conflicting data to avoid corruption. And finally, there's a process for saving the insights, which we'll call the sedimentation loop. Okay, step 1. The user doesn't just ask a question, they inject a persona.
They literally command the AI to become report summarizer number 1 and to use the precise format of a sell-side equity research report, the kind of superstructured analysis that investment banks produce. This immediately activates that persona layer and sets a professional tone from the get-go.
Second, they enforce one of the most important rules from that root layer we talked about. You have to separate understanding from execution. The instruction isn't write the report. It's first, give me an outline. This forces the AI to plan its entire logical flow before writing a single word, which ensures the whole argument is sound right from the start.
Third, they establish rock-solid global boundaries. To calculate TSMC's revenue pool correctly, you have to be incredibly precise about what actually counts. So the prompt explicitly includes things like wafer production and advanced packaging, but it strictly excludes everything else, from memory chips like HBM to circuit boards. This prevents what's known as scope bleed and keeps the math totally pure. Now here comes the critical moment. A new, conflicting analysis is introduced into the mix. But instead of just dumping it in, the user gives a very specific command. Produce another output, but do not let it affect our previous research report. This single sentence is the trigger for what's called cross-project containment. And this just brilliantly illustrates what happened next. The AI OS, following its rules, recognized that the new data had a totally different scope. It included the entire server cost, not just TSMC's part. So it created a separate comparison document isolating the new model as a high-case sensitivity scenario and protecting the original report from being corrupted. It's fantastic.
And finally, once the analysis is complete and validated, the user gives the final command to organize and update this to the LLM wiki. This activates what's called the sedimentation loop, where the key findings and the logic are saved to a central knowledge base. And this turns a one-time analysis into a permanent, reusable asset for the entire system.
So what this whole 5-step process really shows is a fundamental shift in how we should be thinking about working with AI. It's a move away from just asking questions and, hoping for the best.
We really need to stop acting like simple conversationalists, just hunting for a lucky answer. The new paradigm requires us to become architects, or what you might call workspace maintainers. Our job isn't to just prompt, but to design and maintain the disciplined environments where AI can consistently and reliably do its absolute best work.
And that leaves us with one final provocative thought. When you sit down to work with an AI, are you just talking to it? Or are you taking on the role of an architect and actively building the world it needs to succeed in? The difference in the result, as we've seen today, is everything.